We have a saying within E&I Space, space is hard. Everybody says this in the industry. I like to say propulsion is harder. Like we were these three university students from Spain competing against Washington State and MIT and Georgia Tech, and we were actually able to bring home the award. I think we got $1,000. We're still in university back then, so we used it to party. Basically, I'm not gonna lie. I had a moment in early 2020 where we hadn't been able to basically raise any significant cash. I mean, we thought, well, they're not going to give the funding because like who would give funding for like a space tech company in the middle of the pandemic? And we actually made a decision to close the company. And then
Space is humanity's greatest laboratory. Defense is democracy's strongest shield. And today, in workshops, in laboratories, in startups, a new generation rises, not to observe history, but to write it, where every innovation above drives progress below, where every breakthrough in defense preserves our freedom to create. Behind every breakthrough stands a founder with a story. Now these stories emerge to light the path for those who follow. Welcome to Rockets and Radars.
Hey Daniel, before we dive into our chat, grab your drink of choice, which is water for you. For me, it's my favorite coffee. And let's both get comfortable as if we were in a pub. Your story is super interesting. You went from researching plasma physics at university to building a company that's revolutionizing how satellites move in space, securing 10 million euros in public plus private funding, and putting the first European ElectroSpray thruster in orbit. I want to really understand not just the company journey, but also the person behind this journey yourself, the highs, the lows, and everything in between. So let's get into the chat. I'm very curious where we will end up with this conversation. So first things first, give us a 30 to 60-second pitch for Ienai Space, especially for people that might not know you yet. What is the problem you are solving and for whom?
Okay. Well, first of all, thank you for having me, Martin. It's a pleasure to be here. So so I'm the CEO of E&I Space. E&I Space is a space mobility company. We like to say that it's space mobility because typically a company like ours would have been thought of as a propulsion provider, right, in the past. But basically, when we started the company, we understood that the know-how behind propulsion is also something that is very valuable to the industry, right? So yes, we do manufacture propulsion systems. We have an electric propulsion system that is aimed at small satellites primarily, and I can get into the technology later in a little bit. But it's a high efficiency, high compactness, low power propulsion system that is currently aimed at CubeSats or small microsats. And that is very disruptive with regards to the existing offers in the market. But as I said, for us, it's not only about propulsion, it's about the propulsion know-how or propulsion related know-how. So on top of our propulsion system, we're building an ecosystem of other products that are trying to condense all that knowledge into basically software tools that are useful for our clients. And that's why we talk about space mobility, because we believe that space mobility encompasses a lot of different moments throughout the definition of a mission. And what we're trying to do with our software tools basically is address, let's say, the mission definition and platform design side of things. That's with one of our software tools called 360, which is a mission and space mobility analysis software. And then in the future, we're also going to be moving into the operations side, because we believe that as providers of a propulsion system, we are best suited to help our clients use and get the most out of our propulsion system. So we want to help them with the operations as well. And basically what that does is we're going to be able to have this kind of like end-to-end ecosystem of products and services, both hardware and software, to complete the full value chain related to space mobility.
Awesome. That was an amazing pitch. Now we know pretty much everything. And now let's get into the chronological story, which I'm super interested about, and especially about the product evolution. That's my highlight here. I would love to get into that. But anyway, before we get into the very beginning, I would love to understand you from the personal side. Who is Daniel when he's not building space propulsion systems or space mobility systems?
That's a really good question. I've had this question asked before, and it's not easy to answer, perhaps. But I would say, mainly I'm just a curious person. I think most research that you find out there, most founders, most entrepreneurs, most engineers, right? Like they're just curious people by nature. I would say that, I think the term creative has also been kind of mainly used for more like I don't know, like more artistic side of things, I think generally. But I think we engineers, we scientists, like we are very creative in nature as well. So I think, at the end, having a company is basically like the ultimate expression for me regarding being able to create something.
I really like your approach, the artistic side of like a company
Mhm.
is an art in one way or another.
Yeah,
Everything falls into it. Awesome,
yeah.
awesome. Cool. Take us back to 2017
Uh-huh.
when everything started. What
Sure.
made your research at the Electric Propulsion conference stand out, if that was the very first part of the start of the company?
So we hadn't started the company back then. Basically, I started the company with two co-founders, Sarah Correllero and Mick Binen. They're my co-founders, and we met during our PhDs. At the time, we were still carrying out our PhDs at Universidad Carlos III de Madrid here in Madrid, Spain. Basically, the International Electric Propulsion Conference is the biggest conference, the biggest scientific conference related to electric propulsion systems, right? And they did something I thought that was very cool, very innovative back in 2017, which was to propose a kind of Young Visionaries Award for the researchers, the young researchers that were, let's say, working on the field. And what that award was focused on was on basically producing a paper and producing a piece of video, basically like a video explaining that paper, in which basically what they were looking for was a visionary look into how electric propulsion systems could revolutionize the future of space. And what we did, we did two things basically there. So we proposed a mission concept for deploying a lunar positioning system, so kind of like a GPS but on the moon, using electric propulsion systems to do let's say, the orbital maneuvers required to go from, in this case, geostationary transfer orbit all the way to the moon. And so that was already quite innovative, I would say, from the start. But at the same time, what we did is we used software to analyze not only like the best trajectories for there, but we coupled the design of a particular propulsion system that one of my colleagues was working on, in this case, electron cyclotron resonance thrusters. So the design of that thruster to the mission as well. So we had basically an algorithm that could optimize both the trajectories to the moon and, let's say, find the right combination of propulsive parameters, basically, that would enable to optimize, let's say, that full mission. And in fact, that was kind of like a very early iteration of what we're doing at E&I. We've talked about software, we've talked about hardware, right? So we keep on having this philosophy of, hey, we want to be able to make sure not only to give you the best propulsion system, but to use our software to understand what customization options we need in the propulsion system to address a particular mission. So that idea was right at the start, in the founding of the company. And we basically proposed this. The partner at the time of one of my co-founders was an artist, so she actually made the drawings for that video, and we did this kind of
Mm,
like, kind of like sketch. It was at the time, and on YouTube, it was very common to have these kind of like sketch on a
yeah,
whiteboard.
yeah.
We were kind of like sketching out the solution on a whiteboard and like taking users, or taking people that were, or viewers, sorry, through the solution and what we were proposing. It was kind of like a visual summary of the paper. So I think also at the start, we were also concerned with like being able to communicate right and being able to, tell the story right. And we ended up winning the award. We ended up winning the Young Visionary Award, or competition, sorry, in back in 2017 in the International Electric Propulsion Conference. And it was just, it was a whole moment for us, right? Because like we were these three university students from Spain, from a university that wasn't very well known for electric propulsion research, from a country that wasn't very well known from electric propulsion research. And in fact, until Ienai was born, there was no company commercializing electric propulsion systems in Spain. And
Mm.
there we were in Atlanta, competing against Washington State and MIT and Georgia Tech and, all the big US universities. And we were actually able to bring home the award. So that was a really,
Awesome,
really big.
awesome. Did you get any money or cash on hand
I
alongside
think
the
we
award?
I think we got $1,000.
That's enough to start.
And I think we just used it to I mean, we're still in university back then, so we used it to party, basically. I'm not gonna lie. But it was, it was the success that counted, and I think we had fun with that cash.
I will get more in depth within this period of the journey, and that is co-founders Sarah and Mick.
Yep.
Can you remember what was the first time when you meet them, and did you know that you would work together?
So yeah, I mean, I started my PhD a little bit earlier than they did, and we met kind of when they started in the department. I think we got along well initially, just kind of like as new people that would meet and working in the same department. But I think more and more we would talk about let's say what we were going to be doing after the PhD, and I think for the three of us, it was clear that academia was not necessarily where we wanted to remain.
How so?
Let's say the three of us come from different or PhDs were differently oriented. Mine was in simulation of plasma physics for Hall effect thrusters. Mick was building diagnostic hardware for testing propulsion systems, and Sarah was doing kind of like a little bit of a mix of simulation and hardware. She was trying to build a new propulsion system based on the ECR technology. Um, but I think what we saw basically was that the plasma-based technologies, and we were in a plasma-based or plasma-oriented research group, right? So like plasma-based technologies could simply not provide the level of efficiency that was basically reaching low powers that would be required for this kind of new thing, or it wasn't new at the time already, but kind of new to us, which were CubeSats, right? So CubeSats, again, this was like 2020. I started my PhD in 2013. CubeSats were kind of have been around since like the early 2000s, so like maybe 10 years of CubeSats. But I think initially it was mainly like university oriented and kind of like amateur oriented, and then like at some points people started using it. And I think Planet at the time was like, people were listening about like Planet doing these crazy like Earth observation with CubeSats, and CubeSats were going to be like the next big thing, right?
Yeah,
And
it was
we
kind of like a bubble, not the pure market bubble, but the
Yeah.
people were overexcited about this.
I
But
think the
yeah,
technology, but I think the technology bubble was a little bit real. And if you see the market today, it's definitely going to. I mean, it's not. It's moving away from CubeSats to like larger platforms, right? I mean, it's like 100 kilograms, 200 kilograms, 300 kilograms. That's probably
hmm,
going to be more the norm, maybe even larger than that. So I think CubeSats at the time were, yeah, it was expected that that it could solve a lot of the entry barriers for space. And what we saw there basically was that, first of all, there were no electric propulsion technologies that could fit in CubeSats, basically. Like, that was the truth. And secondly, that the technologies like miniaturizing plasma-based technologies was just not going to cut it. And so we were talking, we could keep talking about like, hey, but like there's this development within the space industry. People are like moving to new space. People are like, moving to CubeSats, and there's just like no propulsion solutions for that. And I think we just kept thinking like, yeah, our research is cool, but like, who's going to like provide for this market that is growing, right? And that was, I think, one of the initial things that led us to the selection of the technology that we employ in our Athena thrusters, which is ElectroSpray technology, which is not a plasma-based technology. It's still electric propulsion, but it's not a plasma-based technology. And the initial conception, which was again very focused on CubeSats, although now we're again also kind of like trying to match the market and go into larger propulsion systems.
okay, awesome. One more question about your co-founders, and then I would love to get into the commercialization.
Okay.
Going from research. So a lot of people that are still in the research, either in engineering or in similar verticals, when I talk to them, they struggle to get the right people to start business with. Would you have any just thoughts for other engineers or researchers that might be at the phase where they really want to start something, but they don't know if they should do it alone or they don't know where to look? Like, what would be the idea for them?
So I had this same conversation with a founder actually last week, because I'm mentoring some kind of like early founders as part of the program here in Spain. And I think we were very lucky that we obviously knew each other from carrying out our PhDs. We knew each other from working together in prize for the International Electric Propulsion Conference. I think that we kind of like had that initial thought of like, hey, we're friends, like we get along well together personally. We have kind of like similar ambitions, and it seems like we work together well, right? I think we were very lucky because it was kind of very organic in the way that we found each other as kind of founders. And in fact, I remember initially when we were going through a lot of the kind of like startup accelerators and incubators, a lot of people were saying like, you shouldn't have your founders shouldn't be your friends. Like, you shouldn't bring friends to like a founding situation. And you know what? I mean, over the years, I have to disagree with that. I think the fact that we were friends, the fact that we had a personal relationship, the fact that we saw each other outside of work, the fact that we, we're friends or maybe like even family, to a certain degree. Like I see them more than I see, my family basically sometimes. I think it's helped. I think it's helped with the difficult moments. I think that respect, that kind of love for each other in a way is something that's I think helped, fueled the company in many ways. That's not to say that there haven't been issues or complications with founders. Like, I mean, I think there's some statistic out there of like how many companies actually fail due to like founder issues, and I think it's a lot of them. So we have had founder issues. But look, we come at it from, again, from like a viewpoint of respect, of like shared ambition, of like having built this together, and I think that helps us. So one thing I would recommend. So again, like I didn't have the experience of having to look for a founder, which helped us, of course. But I would recommend not doing it alone. I think being a sole founder, or yeah, being alone in a company is definitely a recipe for disaster, in my opinion. I think probably 2 founders, 3 founders, 4 founders, that's kind of like a good number. And in terms of like, yeah, finding people, I mean, the things that work organically in life, right? Relationships, whatever, are typically the best. So I would try to, if you can, new founders, like, put yourself in situations where you might meet people in an organic way, right? Like go to a networking event, talk to potential colleagues, go visit research centers, that kind of stuff. And just try to find the people that, again, that you feel comfortable working with, that you feel comfortable on a personal level, that you have a
That's a good one.
similar.
Super.
And
Thanks for sharing.
yeah,
Awesome. Let's get into the transition from research to commercial enterprise. So now, if we get to the timeline, you just got an award, you got back from the US to Europe, you spent your reward on partying.
yeah.
And right after that, give me all of the specific steps you took to make your research commercially viable, or in other words, how did you make your research a business?
Right. So, I mean, one thing I want to say is that we didn't actually use any of the research that any of the founders actually carried out to start the company.
Okay, fair enough.
We kind of decided to go for a completely different technology than any of us were researching, which is this electrospray technology, right? And the reason was that but what I do want to say is that what we did bring was like all that know-how that we had developed during our PhDs, right? Like the knowledge on the market, knowledge on the technologies, knowledge on how to build a technology, knowledge on how to build diagnostic systems for electropropulsion, which is a very niche thing. Like we brought all that knowledge, and we said, let's look for a technology that is actually going to work for CubeSats. That was the initial point. But going back to your question, so I finished my PhD in 2018. Mick and Sarah were still involved in their PhDs, and actually they were involved until 2020. And then basically late at the end of 2018, there was an event in Vigo in Galicia in the north of Spain, that was called New Space Spain Vigo, and it was like an event about new space in Spain. It was the first time that it happened. Got hold of it. It came into a radar basically the day before the event was happening. We used our university contacts to ask if they could give us some free tickets because we couldn't pay for them. And then we basically took a flight at 5 a.m., which actually almost turned back because of the bad weather in the north of Spain. And we went to this event. And basically, during that event, we had a first taste of what the Spanish space market looked like, of like the players. And there was a lot of questions about electropropulsion. Like there was basically the intent at the time was to say, hey, Spain should be able to have a complete supply chain for all the elements that are required to build a satellite. And then a lot of people were asking, what about propulsion? And there was basically no propulsion manufacturer in Spain. And we said, well, that could be us, right? Like that could be, yeah. So that was our first taste of like who our clients could be. And then we came back, we kind of like started doing some market research. That was mainly me at the time, just trying to understand how we would position ourselves, that kind of stuff, just trying to get an idea for what we were trying to build. And then basically early 2019, we funded the company. We basically founded the company. And I have to say that the first 2 years were very difficult. I was maybe under the wrong impression because I had a lot of friends at the time that were entrepreneurs. I still have friends that they're still my friends, but I had gotten kind of like a taste for entrepreneurship from kind of like my personal environment and personal circle, and I thought this can't be that difficult, right? It seems like building a company is something that can be done, and also I was thinking like no one else is doing this in Spain, like we're gonna be the only ones, like we're gonna get a lot of money, we're gonna get well funded, that kind of stuff. I was so wrong about both of those things. Building a company is not easy. Building a company in Spain is not easy. And getting funding in Spain or in Europe, especially for space, I think at the time back in 2018, I think now is a little bit, more
Mm.
better considered, was very difficult. And the first 2 years were actually very difficult. We we had a moment in early 2020 where we hadn't been able to basically raise any significant cash. I mean, I think we had done a couple of contracts for like about 30K, just some like kind of like side quests, stuff like that, to do a little bit of bootstrapping. And then early 2020, we basically like were running out of cash, and we had asked for this grant from the government of Madrid, from the where we are. And they were, COVID came, right? And then we were not getting a reply from them. And we thought, well, they're not going to give the funding, because like who would give funding for like a space tech company in the middle of the pandemic? And we actually made a decision to close the company. And then that same day, we actually received the funds that we were expecting. So we turned back on our decision. We saw it as a sign that we should continue. And then it was a little bit easier after that, and that allowed us to start paying ourselves and start to get, to actually buy things that we needed for the lab and hire our first employee and that kind of stuff. And
Tell
then
me more about this source of funding.
so
Where
it
did
was
you
it
get
was
it? What was the
yeah,
source?
it was a sort it was funding from the Comunidad de Madrid, from the region of Madrid. I think it was like 90K, so it wasn't that much money, to be honest. 90,000.
90,000. Well, that's good.
Yeah, it was good. It was pretty good. It was pretty good, considering that it was like equity free and so on. And the point was to, and I think at the time we kind of had proposed the development of like the whole propulsion system on based on 90K, which were like, we were so off by so many orders of magnitude in terms of what would be needed to develop the propulsion system. But in any case, we got the funding. We were able to mention that we had done the developments that were critical and so on, and we were able to complete the project. But yeah, that funding was actually very critical, and it saved us from basically closing the company down.
Awesome. Before we get further in the journey, I want to go a bit back and deep dive more into the market research. You took the whole journey very systematically, which is
Yeah.
interesting. But tell us more about market research, because this is the problem, the biggest challenge that most of the founders probably have, like how to calculate the market, how to know like where to look for the numbers. I see some founders like either making up numbers or trying to find something very generic. What was your approach?
So I think we were very lucky, because at the time there was it still exists, but there was a page called nanosats.eu, which I'm pretty sure has been used by 100,000 founders in space to like have a first address on the market. And because we were focused on CubeSats, we could see there was information about how many CubeSats were being launched and about how few CubeSats actually had propulsion on board. And I think where we made our bet was to say, hey, you know what, with this whole thing about like space debris and space junk and so on, it is at some point going to become a requirement to have propulsion on board, so you can avoid collisions and deorbit at the end of lifetime. And we did this prediction in 2018. We thought that this would happen around 2030s, around the 20s. But in fact, it happened earlier, because Congress, the U.S. Congress last year, and the Federal Communication Commission have now started to, I think it was as early as 2023, the Orbits Act in Congress and the resolution from the FCC, to make sure that you have the capability to deorbit your satellite at the end of its lifetime within a time frame of 5 years, which was much, much more stringent than the 25-year guidelines that had existed in the space industry for a while. So in fact, this happened a lot earlier than we thought. But going back to your question, yeah, that first address of the market, I think that was completely nanosats.eu. I can't remember. I used to know the name of the guy that worked on that page, but huge shout out to him if he's listening, because I think that's basically how we were able to do the market projections at the time. And I have to say that we were also part of a university kind of like incubation program called Actual UPM here from the Polytechnic University of Madrid. And I think they gave us a lot of tools as to how to quantify the market, how to do the business canvas, how to, kind of like those initial, kind of like really thoughts about like who your clients are going to be, what's your value proposition, who are the stakeholders, all that kind of stuff. So we went through that process in a very structured manner. And I really appreciated that, because I think it allowed us to put structure into our thoughts and basically to deliver actually like the first investment pitches and like the first kind of like business market analysis and stuff like that.
Awesome. So you got the 90,000 check from the local authorities. What happened after? Product-wise, team-wise,
Yeah.
funding-wise?
So, I mean, we started to be able to pay ourselves, which was not a small feat because we were surviving on, in my particular, Mick and Sarah were still working on their PhDs, so they were still getting paid by the university. But I actually had a second job as a tour guide, nonetheless, to be able to afford rent and food and all that kind of stuff. Yeah, so we were able to start paying ourselves, which is, I think, a big milestone that we needed. We hired our first employee, and we basically started to look for help in people that could help us manufacture or some of the critical technologies that were required for our propulsion system. So basically electronics and what are called the ElectroSpray emitters. And we started to, we outsourced some of the initial electronics. We bought some laboratory electronics. We were able to come to an agreement with our old university department to fix an old vacuum chamber in exchange for being able to use it, so that we could use that vacuum chamber to be able to test the propulsion system. Actually got in touch, and this was another thing that was kind of, sometimes you're lucky, but Sarah actually had a childhood friend that was working on micro manufacturing. He was doing a PhD in micro manufacturing, and he actually offered to deliver the first electrospray emitters, which are micro manufactured using lithography, same as electronic chips and so on, to deliver the first electrospray emitters. And we were able to test those, right? And we were able to test those in house. And then we partnered with we signed a contract with a research center here in Spain, in Barcelona, which is the CNM, which they're our partners up until this day. And this is one of our main manufacturing hubs for the electrospray emitters. And they produced the first version of the current configuration that we have for the electrospray emitters, which are called externally wetted. That's a technical term. But they were able to produce this in basically second half of 2020, and we were able to test those emitters in basically end of 2020. So to be honest, even though we started the company in early 2019, I have to say that in earnest, we didn't really start technology development until late 2020. The first test of or electrospray emitter was in October of 2020. So whenever I look back and I try to think about like how much time we've been doing this, which now is 6 years and it seems like a long time, I have to remind myself that it was kind of like late 2020 where we actually started with technology development.
Regarding technology, there are two tribes of founders: those that love full vertical integration and those that love to horizontally outsource different parts of their tech.
Yeah.
Which tribe are you in?
We're in the first tribe. We do everything for the electropropulsion system, and this was based on, to be honest, this was based on an early piece of advice that we received because we also went through the Airbus accelerator, so through what was called the BIS lab at the time, and we were in touch with the team at Airbus that was responsible for electropropulsion integration. They don't develop, but integration into the satellites, and they had been working with a lot of companies, European companies like Safran, and which were doing traditional, let's say, electropropulsion systems based on plasmas. And one of the recommendations that they had from having interacted with these companies was, look, electronics are 50% of the value of your electropropulsion system, which is true. Like if you look at the criticality of the electronics is big. And they said, if you outsource that technology, if you outsource the development of the electronics, it will cut away from your margins crazily. And in fact, they were saying that, a lot of companies in Europe had initially done this and then had turned back and started to develop in-house the electronics. So we made a decision right from the bat of saying, like, look, we're a subsystem integrator. We're going to deliver a subsystem, but we're going to do the whole thing ourselves. Of course, right now with where we are, which is basically about to do our first launch of a first flight model, which is representative of the commercial system, of the commercial electropropulsion system. What we have done with the electronics is like we've developed them in-house, we've prototyped them in-house, tested them, and then now we're relying on a number of partners that have basically meet the standards for both military and space applications, which it's a complete other, kind of like complete other world. So they manufacture or designs for us with the standards that are required to meet like the specifications in the space industry. But we still design everything and we manufacture a lot in-house as well.
Is there any scenario, let's say that you didn't start on work on this tech, is there any other subsector in the space industry where you think that vertical integration doesn't make sense in the beginning?
I mean, it's a big question, right? I mean, I think it depends on what you're doing and what the size of your cash reserves look like, right? So I mean, I think a lot, launches, because SpaceX did vertical integration, launchers have kind of gone crazily into vertical integration. Here in Spain, we have PLD, right, which are trying to do vertical integration. I think that's something really hard to do. ISAR is trying to do vertical integration. There are other launchers that are not doing that. In the US, most launchers are not doing that. So I think following the SpaceX playbook, when you had access basically to NASA technology and quite a little bit of funding initially, might not work for everyone. And in fact, for example, Relativity Space, which was doing vertical integration, has now reportedly moved out of that and is buying some components from the Ariane 6 actually, so for their Terran R. So it's difficult to say. I think as a subsystem provider, if, for example, in our case, because we're trying to deliver a subsystem, um, you have to be vertically, like, you have to deliver the
Yeah, there's
complete,
no other way.
right? I mean, there again, like in the case of electropropulsion, the electronics and the thruster kind of like might have gone separately a little bit, in the tanks. So I know people that use providers for the tanks and then use someone else for the electronics and then just kind of put everything together. But I think doing vertical integration. I think you should do vertical integration to the extent that it makes sense mainly with your cash reserves, because the more vertical integration you do, the more margin you're going to have on the product. Basically, that's the business logic. In our case, doing almost everything in-house, even though we then use procurement to deliver some of the components and some of the subsystems in the propulsion system, made sense because that was coherent with our capability to raise funding and to develop this, and would allow us the maximum amount of margin to be recuperated, basically, or to be kept within the product. And I think that's the conclusion at the end of the day. If you don't have the cash reserves, you might need to outsource, and then so you basically you outsource as little as you can to make sure that your margin is as high as you can. But that has to fit with your cash reserves, basically, in your business plan.
Very good summary. Thanks so much for sharing your insights here. Okay, before we get into a big milestone, securing your first millions in funding, I would love to zoom out and ask you if there are any big learnings or insights before you reach that funding round that you would love to share with founder community and engineer community.
Yeah, I mean, building a space company is difficult. Talking to investors is very difficult. I think, especially at the time, there was very little interest in investing in at least in Europe, right? In the US, it was different, but like there's very little interest in Europe in traditional VCs investing in space. And I would say, like, never underestimate the amount of time that you're going to take to raise a round. Like I think it took us, like, probably like the first round, it took us like a year of negotiations just to close that round. And I think I've heard people think like, oh, we're going to do it in 6 months, we're going to do it in 4 months. But never underestimate the amount of time that you're going to need to close a round.
By the way, if you start again, would you start fundraising from day one?
I mean, honestly, if I'd start again, the best situation I could possibly hope for would be to put in some of my own cash, so that if we do exit E&I at some point, putting some of my own cash to make sure that we have, I don't know, 100K, 200K in the first year, so that we can start to hire people and do things. We basically literally started E&I with no money, like, and you have to also think about the fact that we were coming out
Impressive.
of our yeah, well, we were coming out of our PhDs, right? So, like, it's not like PhDs are very well paid, especially not in Spain. So we basically had no cash reserves, and that is the one thing I would not do again. If you can, and we didn't want to, we didn't do the triple F, right? Like, we didn't do family, friends, and founders. I mean, the founders put some money, right? But, like, it's not a lot. But we could have done a triple F, and it seemed so crazy at the time, like, to be able to build an electropropulsion manufacturer in Spain when there was no background on it, no heritage in these kind of technologies, that we felt that it was unfair to fools and family to kind of put the risk on that, right? And especially because we knew that in Spain, one good thing I have to say about Spain is that you do have access to quite a lot of public funding. We've raised about 5 million in public funding in total. And that's been very valuable. It takes time. It takes a lot of time, which means that a lot of companies can die along the way. But if you can wait, that non-dilutive funding, I think, is very important, and Spain has a lot of it.
Would you have any practical lessons on how to navigate the Spanish public funding ecosystem?
Yeah. I mean, there's the very well known, I would say. I mean, you have to look at it from both perspectives, right? The regional one and the national one. Regional one, typically, like there will, if you just do a Google search, there will be all these calls for innovation, technology development, that kind of stuff. You can go out and look at what your regional government is offering. Some regional governments offer more than others. For example, right now in Catalonia and Galicia, there's two. Basically, the government is really interested in creating these like space tech hubs, and they're funding a lot of companies there. Madrid is not that so much interested in new companies because Madrid has traditionally been where most of the space tech companies were. And so we've kind of had to not rely so much on regional funding, even though our first check was regional. And then you have like the national funding, and the national funding, the big ones are Neotech and NISA. I mean, you can check, but anyone doing a Google search can check. But like, there's a couple of like big ones that you need to apply for that will give you your kind of basically your first million and undiluted funding. Yeah, I mean, those are the ones that I think all tech entrepreneurs, especially deep tech, should apply for.
Okay, awesome. Let's get into the first million in seed funding. What is the story behind that deal, which happened around 2021, if I'm right?
Yeah. So let's see. So during Actua OPM, which is this incubator program that I mentioned, we met Francisco Berlanga, which ended up being our CFO for 3 years. He left the company to actually raise his own fund afterwards, but he was our CFO for 3 years. And he had been involved in other startups in the past. He knew the ecosystem well. He knew what the investors wanted to hear, I think, mainly, having been an investor himself as well. So I think what happened basically was that he put us in touch with the director at the time of the fund, which is Inverredi, which was our first VC backers. They're in Barcelona. At the time, we were already collaborating with the CNM, which was in Barcelona. So they liked that we had this kind of like regional connection. Spain is very regional in that sense. VCs can be very regional. So it's not even at the national, sometimes you say like, oh, I'm looking for European funding, and you have problem at the national level, but even in Spain, it can be at the regional level. And so we initially got in touch with one of the partners in the fund, and that fund was, had a track record of investing in biotech companies. So they kind of knew about a sector that was like, long lead times and long time to product and things like that. So at least it wasn't like that they were only focused in software or things like that. So initially we had some chats with the partners, and I think because they were coming from a biotech background, they were not so scared basically of investing in a company like ours. And then unfortunately that partner left. And we were trying to get in touch with them. We were trying to like recover those conversations for quite a long time. And it happened that they actually had invested in another space company in the past that was doing orbit determination for geostationary satellites, which is actually kind of like a bit of a complex problem. A bit early for the market, because now companies are doing this and they're succeeding. But I think at the time it was just kind of like, it was a problem, but it was early for the market. And this company closed down, and I think they were thinking like,
Not again.
we wanted to no, kind of like the opposite. Like, we wanted to have a space tech company in portfolio, right? And they were talking to a number of companies and so on. And I think I think the ticket that they put in, which was actually like 500K, not 1 million. It was a 1 million deal, but like the ticket that they put initially was 500K, was on the order of magnitude that they were kind of comfortable with doing. They wanted to keep a space tech company in their portfolio. They wanted to kind of like build this thesis. To be super honest, as far as I know, they have not invested in space afterwards, but they're happy with us. They're very happy with us. Actually, I think they invested in Pangea Aerospace, which is, they're doing rocket propulsion. And I think also that was a good thing, because at the time they were talking with Pangea, and Pangea is like, they're doing launcher rockets, which is a much more capital intensive effort than what we're doing. I think even though they invested in Pangea eventually, I think it was good that we could show that we could do things for less money. And so it was kind of like a combination of things. We ended up kind of like being able to get back in touch with them, get back in touch with the partners, even though this original partner had left. We had made a really good impression in this partner, so he was still, I would say, highly regarded within Inverredi. And I think what we proposed to them made sense to them. It made sense to them from the ticket size to the company type and that kind of stuff. And I think they were trying very hard to build that space tech thesis. And we were lucky enough to have them bring us on board as part of their portfolio.
You mentioned that you did more with less money. What were your creative approaches to minimize the capital requirements for your product?
Look, I mean, the fact that we've done more with less money is very apparent. If you look at the EP market in Europe, I can say Morpheus, for example, competitor of ours, raised, I think, 28 million. You can look at Exotrail, raised 56 million. You can look at IonX, raised 4 million in seed when we raised, pre-seed when we raised 400K, and now has raised, I think, 13 million. So and we've done 500K in pre-seed, and then 4 point something million in a seed round, right? So I mean, the fact that we've been able to do more with less is apparent, right? I think the fact that we're in Spain is good. I have to say, there's a bad thing to Spain, which is like salaries are typically lower. We were able to hire initially quite a lot of people for salaries that were not as crazy as probably like the French ecosystem or like the German ecosystem. I think that helped us keep the costs down. But I think that the main thing was that we asked for a lot of favors. We did a lot of things for free those first few years. We had people manufacture things for us for free. We had access to facilities, to vacuum facilities for very little money. We started out very small. Our first vacuum facility was this tube, basically a tube that you could connect a vacuum pump to it on one end. It had a window on the other end, and that's where we were testing our first propulsion systems. We did things, garage style. We actually worked in a garage because the laboratory that we had initially was in the university, was in their garage. We then moved to some offices where actually it was something that Town Hall of Madrid was offering for tech companies. Like they were offering free offices, right? And we moved into those, so we didn't spend any money on free offices. We paid ourselves very little. Like my initial salary with E&I Space was 12K. That was the initial salary that the founders put ourselves in. Okay, so like basically enough to survive. Like that's basically it.
I love that scrappy approach, but that's what
Exactly.
made you
Scrappy and
different.
just demonstrate as much as possible, and then keep building it. So I think we were, we knew the value of money. We did not waste money, I think, in any way. We asked for a lot of favors, and I think again it's a testament to the fact that we've been able to, to be on the same level than other companies that have raised, look, multiple, 5 times, 10 times more than we have, basically. Like, and we're there, right? Like we are there. And I have to say, I think we've been really good at public funding. Again, we've raised about 5 million euros in public funding. 2 of our current in-orbit demonstrators are funded by the European Commission. On my spare time, you asked, who Daniel is. On my spare time, I like to write short science fiction stories. So I think I'm a good writer. My brother is a writer, actually. And so I think it runs in the family a little bit. And I think we were really good at expressing ourselves in these kind of public financing.
Yeah, cool. I'll put your contact information in the description. If there is any other founder that would love to get any help with public funding, you are their guy.
That's perfect. Yeah, happy to help.
Regarding demonstration, let's get into a bit further in the journey. October 2022, where you got your flight heritage. What was the moment like, and how did you get into that point?
So so that was that was a bit of a crazy story. We were talking with a company in Spain that was doing pico satellites, and we knew that the technology, the ElectroSpray technology, could be miniaturized down to pico satellite format. Which, by the way, I mean, there's been attempts to do that. There was a Swedish company, Pork Chop, that closed down trying to do that. They really tried really hard. It's very difficult to scale down to something that is basically about the size of, kind of like, this size. Like scaling an electric propulsion down to that system is really difficult. So we thought our technology could do it. We were talking with a company in Madrid that was trying to launch a pico satellite that was part of the Firefly Alpha 2 mission. They had the launch for free, and they wanted to incorporate an electric propulsion system on it. And they said, we're going to be integrating or finalizing the integration in about 3 months. Can you deliver anything in 3 months? And
did you know them before, or they?
We've been talking with them, but they had this opportunity to launch with Firefly, and they were like, we're going to be delivering the satellites in 3 months. Can you do something in 3 months?
What was the name of the mission?
It's called the mission was called it was Firefly Alpha 2. It was to the Black, the launcher, and then the company was Hydra Space, which is still delivering pico satellite thrusters for IoT purposes. And we we were trying to do something bigger. We were trying to do some, CubeSat size, which is, kind of like a U or something like that. And we were like, if we push it, and we kind of found some commercial high voltage converters, and we kind of scaled down the low voltage electronics, and we made the emitters really small, and we were actually able in 3 months to fit everything into a prototype that fired in our laboratory. And then we did the qualification. We went through vibration, shock, thermal vacuum. We broke a few thrusters, to be honest, on the first try. We moved away from some of the fabrication technologies that we're using for the electrospray emitters, particularly, that were making them very fragile at the time. But we were able in 3 months to kind of couple something together. I think that was a great effort from the team. I remember going over every weekend, basically, for those 3 months to the lab to put everything together and do the tests and so on. So we went through this whole thing, and then we reached space. We got a video of where our thrusters were in deployer from LibreSpace organization. We were in there, and then basically what happened is they deployed the satellites, and unfortunately the second stage of that Alpha 2 rocket didn't circularize the orbit, which meant that we were in a much smaller perigee than it was expected. And that meant that, basically that the satellites were going to deorbit in about a week, when we were expecting months of operations. So I have to say that even though we did get our first flight heritage, we didn't get a lot of information from that mission. Unfortunately, we got some data packets from the thruster, confirming like initial health and stuff like that, but not much more than that. And then we kind of like. But I have to say that we learned so much, right? We learned about integrating with the satellite. We learned about meeting the requirements from the launcher, which for propulsion can be very strict, because they're interested in like material compatibility and like things related to propulsion. The propellant tanks and things like that. So we learned a lot.
What is the top one learning from that period that you remember?
Top one learning is that integration, even if it's a relatively simple system that has 3 subsystems: electronics, propellant management, and the thruster, can be more difficult than you think. We were debugging an issue with the electronics, I think, for the last 2 weeks, and it was driving us crazy because we didn't know what was happening. And basically, for those of you that know about electronics, there was a brownout. We were losing power to the board when we were raising the voltage in the voltage converters that we were using for the high voltage converters that we were using for the electrospray emission. So it was basically pulling too much current, and basically shutting down the communications, the microchip, the communication with the satellite. So we just raised slower. We just kind of we did a lower slope to not pull so much current so fast, and it solved our problem. But I remember being in the lab when we kind of figured that out, and that was a very personal milestone for me, in the sense of like, look, I know nothing about electronics, but we were able to pin it down just by putting time and effort in it.
Awesome. Let's get into another huge milestone, June 2024, where you scored around 4 million euros in the next round. What were the key factors that convinced investors this time? And I'm also curious to just get into your head and to see if you have any favorite highlighted learnings from pitching and getting or going through the round and getting the investment.
Look, I mean, so I think my favorite investor, and I'm happy to mention it here, probably my favorite investor conversation was with MIG, which is an evergreen fund from Germany. And I really liked it because the partner that we were speaking to was actually a physicist, and he really got really to the technology and was able to understand all the technical side and that kind of stuff. MIG ended up not investing in us, but it was probably like the best conversation that I've had. And I mean, at the end of the day, as a deep tech company, what you would like is to have a deep tech investor, right? To have people that can speak your language, because I think there's a lot of heritage from software VCs, where they're like looking for that 10x, 100x solution, right? And hardware just does not work like that. You're not going to find a company building a battery for an electric vehicle that has 10 times or 100 times the capacity of current batteries, right? If you're lucky, you're going to find a 2x or a 1.5x. And that's what we're kind of...
Which is still a lot.
Yeah, which is still
0.3x.
Exactly. Like we were saying, like, look, we are twice or even three times as efficient as our competitors. And if you're talking to someone that comes from software that is looking at that 10x solution, they just do not see that as a breakthrough, even though it is a breakthrough, right, on the hardware side. So I think that's probably like the biggest learning. I mean, try to talk to people that speak your language. And in the case of our latest round, we were in talk with GED Capital with their fund Conexo, and they had funded a satellite manufacturer company, which is actually still in stealth, called Schupo. I mean, the name is public, but they're still in stealth. And I think they were, aware of like space sector. They were, interested in, and they had recently incorporated a partner that came from the Spanish CDTI, which is the Center for Innovation and Technology Development. And he used to be the director of that center. And I think this is Francisco Marin, which is part of our board at the moment. And I think he was uniquely aware of the challenges of hey, Spain needs to have companies that are deep tech, right? And I think it was a very personal thing for him. It was a very personal thing of saying like, hey, I'm joining a fund, but I'm going to make sure that this fund invests in deep tech. And it was a very long conversation. It was almost a conversation before the due diligence. So almost a year to the term sheet, which was, again, very, very long. And I think they were, at the time they were kind of closing the fund, and I think they were looking at a lot of options. We invited them over. We showed them our research. We showed them our development. I think they saw a very knowledgeable team, which is another, by the way, you were asking about co-founders. In deep tech, you need deep tech co-founders. I always joke that when you go and talk to these kind of like CEOs that are being moved around from one company to another, or these kind of like venture builders, they say, no, you need a CEO that has an MBA, right? And I always joke that that's perfectly fine if the MBA CEO is willing to get a PhD to understand the technology that his company is building. Because the devil is in the details to a point that if you don't know what the company is doing, if you cannot understand the technology, I don't think you're going to be an effective CEO. That's my personal take on it. So I joke around, whenever someone comes and say, oh, but you need a CEO with an MBA. And I'm like, yeah, sure. If he gets I'll get an MBA if he gets a PhD, right? Like that's a, that's the trade. But going back
Interesting
to your,
take.
yeah,
Interesting
yeah,
take.
yeah.
Anyhow, one more thing that I would love to get into is commercial delivery. So you just recently started to get your product to the first customers. Is that, if I'm right, in early 25?
Yeah. So
Yeah.
as I said, we have both software and hardware. For our software tool, which is called 360, it's a mission and space mobility analysis software. We basically have about 5 user organizations that are using the tool right now. And we're hoping to reach 10 this year. That's kind of like the goal. Yeah, we're basically generating revenues with the tool. So we're very happy about that. Right now, we're happy to make the team self-sufficient, let's say, and to kind of like get back some of the development costs. But I think the software tool is a great way to start to work with companies that in the future might buy our propulsion systems once the propulsion systems are qualified. But talking about that and going back to this initial idea of the Pico satellite thruster, right? So we did that Pico satellite thruster in 2022, and we said we're never going to do Pico satellite thrusters because it's not a market, right? Or it's only a market if someone comes and say we're gonna build 400 pico satellites for something, and then we'll commission 400 thrusters. We knew that the technology was able to do that, but we didn't want to like do our own development unless someone was actually interested. And then basically last year in a small sat conference in Utah, we talked to a pico satellite manufacturer in the US, and they were desperately looking for a thruster for their picosats because like there just aren't that many out there. And it's been a long conversation. Their mission has been delayed, and it's an ongoing process. But I have my hope that we can deliver thrusters to them, and this would be quite unique because these thrusters will not be tested in space before. We will just have them tested on ground, do all the qualification on ground, and then deliver them, let's say, untested to space. Because of the nature of these systems, because it's a small thruster and the requirements are less extensive than in a CubeSat or microsat satellite. I'm pretty sure with the qualification that we're doing on ground, we're going to be okay. So I'm crossing fingers that they make a final decision on us, and that will be our first sale of propulsion systems this year, which we're very excited about.
Awesome story. By the way, I really love your dual approach, right? Get the customers on the solution that they can just start to use right away, and then use that to upsell them into your upcoming product.
Yes.
So it's quite interesting.
that was the whole idea of the business model from the perspective to be able to because look, there's two reasons why we did this. Well, three reasons, right? I mean, one was the fact that we thought that software was really important for delivering a propulsion system that was customized, that could be customized, because you needed to understand to optimize the design of your mission and your propulsion system to fit platform and mission. So that was the original idea behind it. That was the idea that we had back in 2017 and when we presented this paper to the Visionary contest in IAPC. Second point was, look, if we have software's going to be easier and quicker to develop. We can start to generate revenues on software and use those to fund the development of the hardware, which hasn't necessarily happened in as much as we would have liked, but we are closing revenues this year, and it is going to be going to funding the propulsion system. And third is it's about trust. The space industry is a very old school sector. And you need to, because you're sending things that you can't repair, and so you need to generate maximum trust.
At least.
Exactly. Well, at least yes. Yeah, not yet. So trust is. Sorry, I was saying thrust. Trust, which is what I meant, is something that you need to build. And we thought that by having software and having people use our software, we could build trust towards the rest of our products.
Okay, awesome. Before we get into hearing about how you see the future of the company, but also the market, is there any one more highlight throughout the whole journey of the company that you would love to share with the community? I would love to actually talk more, but we have limited time.
One highlight, I think closing the round last year was a big highlight. We've been chasing that for a long time. We knew that we needed support for where we were at the time. And it was definitely a really big milestone for the company. I think a testament to what the team is actually doing. And, but look, I mean, maybe going back to that, I mean, that was more personal on my side because I was working on the round, but the thing I feel most proud about is the team. Honestly, the team that we're building. I was coming down from a conference this morning where I was talking about the company, and we have a little video at the end, showcasing the whole team and just saying why they're excited about working for a company like ours and so on. And the commitment, the work that they put in. Like their passion, I always like to say that I feel sometimes like I'm the dumbest person in the room, like we have a really, really good technical
But
team.
that's good. That's how it should be.
Yeah, which is what you want, right? And yeah, I think what they're building is really amazing. And I think the thing I'm most proud of is the team that we've built. We're 30 people now.
What is your approach to team build? How do you find people that are being added into your team? And has your approach changed since the very beginning? So let's say the first hire versus the hire now.
So the first hire was actually, let's say, a master thesis student that I had during my PhD. So during the PhD, I was doing master thesis. I was tutoring master theses. So our first employee was actually one of my master thesis students, and he's still with the company, by the way. And to be super honest, we hired a lot of our students during the first years of the company. We hired I think 3 or 4 people that was coming from the time that we were doing our PhDs and teaching and doing master thesis tutoring. So that was a first. And then that was the first way that we approached this. And I think we had a lot of luck in being recommended people, to be honest. We were very in touch with universities. We were talking with a lot of university professors. We were talking with a lot of research centers, and we were very lucky to have really good recommendations. We had Francisco Velázquez, which is our first electronic engineer, and has been the only electronic engineer for a long time. And he's really, really good at what he does. And I think we were just lucky to have him recommended and as a kind of like a really smart and capable person, right? So I think initially it was more, again, like our own experiences with students, recommendations that we had from an or close circle. And then at some point, yes, we did start to, kind of like do more outreach on.
And what do you look for, by the way? Is it more the personal traits, or are you looking more into the skill set?
So I think look, I mean, initially we hired a lot of juniors, and that might have been a mistake in some ways. Like we should have probably hired some seniors as well. But yeah, we initially hired a lot of juniors, and so I think there we were looking for ambition, hunger to be in a company, to like do the work, to have different hats, to work your ass off, basically. So it was more about the motivation and basically building them into the like people that were really good, right? Like we had more experience than them, and we were like trying to shape them into people that were really capable.
And how do you know that those people have the ambition? Is there any
Yeah.
question that you use or any exercise to figure that out?
I guess the first question that we asked was like, why do you want to work for a startup instead of like Airbus, right? Like, why you could go to Airbus, right? Like, you go to Airbus, earn probably double what we're paying you, and just have a quiet, like a, you know, easy, quiet job, chill job. And so that was the first question, like, why do you want to work for a startup? And I think you could see a lot with the answers there. And I think we had a lot of cultural fit initially with people that really wanted to be, a small team, basically skunk works, kind of like having
What
all
was
these.
your favorite answer on this question?
I mean, I'm not sure if it was an answer, but I think people that would paint themselves as being a very proactive person that were saying like, hey, I want to work on solving this problem and I want to work on solving that other problem. And I know nothing about it, but I'm going to like, go down into the details and like research what I need to research. And I'm going to read the papers. I'm going to do all that work so that I can go down and like build this in the lab or all that kind of stuff. I think, that kind of proactivity was something that, that we still look for that. I mean,
It's actually
we're
very rare, by the way.
yeah, but I
I
mean,
think.
I think we're lucky in the space sector because space is such a motivational thing, right? Like working in the space sector is people are so motivated, right? To be able to, I mean, you go out to whatever social environment, and you say, yeah, I work, making propulsion systems for spacecraft, and people are like, what? And I think it's very motivating. People are very passionate about what they do.
Now, I would love to get into the future. How do you see the future of Ienai Space as well as the market you serve in the,
So
let's say, next 5 years from now?
sure, next 5 years. So, I mean, big milestones that we're heading towards is consolidating foothold for mission analysis and space mobility analysis software in the market. Hopefully, trying to bring in some users from our competitors there and establishing a big foothold in the market and improving the tool and basically making a tool that is accessible, right? Because if you look at all these engineering tools, they look like, I mean, they were coded in the 80s or the 90s, right? And it's like yeah, I think applications have changed greatly. So making a tool that's accessible but still very engineering focused, and being able to gain a foothold in the market. We have 3 IODs currently, 3 on-orbit demonstrators for our propulsion systems currently booked. We're talking about a fourth one, so that's going to be over the next couple of years, where we demonstrate the commercial viability of our propulsion system and basically put the team to the testing in being capable of delivering a system that works. Then we have a big challenge, which is scaling, right? We need to scale the industrial production of that, so that initially we're hoping to be able to meet dozens of the order of dozens of thrusters every year, but we want to scale that to hundreds of thrusters. And we need to do that over the next couple of years if we want to reach the market. And we want to cater to the constellations that are being built right now, where really they want to build like a satellite a week or 5 satellites a week, right? Like, I mean, we need to be able to match those numbers. So that's going to be a big challenge. And then like the next challenge also is building the next iteration of Athena, which is what we call Athena Micro, which is a much more power dense and thrust dense system. We have been researching micro and nano fabrication technologies that will underpin that development, but we need to put a little bit more focus on that. But if we are able to get to where we think we're going to be able to get to, we could potentially compete with, let's say, mid-level power thrusters such as Hall effect thrusters or other kinds even in the kilowatt range. So if we're able to compete at the kilowatt range, I think that's going to be us, moving into basically providing propulsion systems for the whole market. And then finally, and just to mention it briefly, again, operations. I think there's been a lot of talk about like smart thrusters, about closing the feedback loop for propulsive operations, making sure that satellites can maneuver on their own without human supervision. And that's also something that we want to be able to get into. And we are having some steps towards that, towards automatizing the propulsive maneuvers in space.
Sounds awesome. Thanks so much for sharing your journey. It looks like you have a good plan going from now on. If there is anybody that would love to join the E&I Space, there is a link in the description. And again, one click and they will get to you as a potential hire. And regarding investors, when do you expect to get to the next round? And what type of investors would you eventually try to find? I will also add a link for people that are potentially interested in becoming investors in you in the future.
Well, I mean, we're looking probably the next round is going to be on the order of tens of millions. Like that's 10 to 20 million. I won't
Okay,
disclose exactly how
standard
much, but,
Series A.
standard Series A. So we need a lead investor that is serious about the tickets that they put, right? So I mean, that's going to be the first filter. I would really like to have a space-focused investor. This is something that has kind of eluded us a little bit. I would really like to have someone that is either deep tech or space tech focused investor. Like I would really like to have that. Um, and yeah, I mean, ideally, I'd like to be able to replicate like this conversation that I was alluding to in the past, where where we were having like a very technical conversation and so on. So yeah, but I mean, look, it should be easier, right? Because like we've de-risked the technology, right?
Yeah,
Now that we're going to be flying, so now we only have to scale, which has its own challenges, but it's definitely a different order of magnitude. Well, it's a maybe it's a harder order of magnitude problem in terms of the engineering, because building the thing that builds the thing is complicated and it's difficult. I think Elon said it. It's difficult to build the thing that builds the thing. But at least we de-risked the technology, right? And de-risking is really what we've been about over the last 4.5 years since we started testing thrusters.
awesome. And when are you planning to start fundraising for that round?
So it'll be sometime next year. There's a lot of there's some other non-dilutive options that we're looking for that we're looking at the moment that could help fund some of the initial.
Okay, so 2026.
Yeah, 2026. Yeah,
Okay, awesome. So if there's anybody, you can reach out to
but happy to
Daniel.
start talking now. Because
Yeah, of course, of course.
like these things they take long.
Awesome, awesome. Okay, last part of the episode, quick fire round questions. I have a few questions here, and I'm very curious if you can answer them in a sentence or two. I'm very curious what you think here. What is the most ridiculous investor question you have been ever asked in the
Yeah.
history of Ienai Space?
It wasn't a question, but it was a guy that basically I did the pitch to him, and then he basically read my pitch back to me as if he was like the owner of those kind of like smart ideas. So he was basically trying to convince me of my own business model after I had explained it to him. So I just did not get at all that kind of interaction. So it wasn't a question per se, but it was a very strange interaction.
Interesting. Okay, next one. What is something that everyone gets wrong about satellite propulsion?
I think a lot of people in the industry think that propulsion systems are overpriced. But I have to say, look, we have a saying within E&I Space, space is hard. Everybody says this in the industry. I like to say propulsion is harder. We're really dealing with like physics, engineering, to a degree that I think a lot of satellite integrators never face. So whenever you think about whether your propulsion system is overpriced or not, please consider please consider that we're actually making these really kind of almost miracle or magic systems. Like Hall effect thrusters, for example, have been around since the 70s. The physics underpinning Hall effect thrusters are not understood yet, and yet they still work and provide thrust for most of the satellites out there. It's the same with ElectroSpray systems. So you have to deal with the engineering. We deal with the physics and the engineering. So maybe think about that the next time you think about whether propulsion system is overpriced.
Okay, that's a good one. Okay, next one. What do you know now that you wish you would known when you were starting Ienai Space?
I wish I had known more about talking with investors. I think investors have a very particular way of speaking, a very particular way of having conversations, and I think I was not, as a technical founder and coming from my PhD, I was not necessarily aware of let's say those kind of conversations and the way that they worked. I wish I knew a little bit more about let's say the negotiation and the way to talk to investors and to negotiate. And look, I mean, I love our investors, but I think we could have hopefully we could have negotiated a little bit better some of the terms in the term sheet. But what is done is done, and being an inexperienced founder, I think, has an impact in that sense. So I wish I had known a little bit more about that.
Which specific terms are you tapping into? Just out of the curiosity, and also for the other funders that might be in the middle of the fund.
Mm. Well, look, we had a number of convertible notes over the years. This is typical, and I think things like the percentage of let's say discount on the convertible note, giving investors sole decision on whether they would convert or not on the next round, this kind of things. Like those things can be not that we have those on the term sheet, but it has something that I've seen in the past, and it is something that you really need to think very carefully about. Also, the cap at which those convertible notes convert, because actually, and maybe this is I think a good suggestion or a good tip for founders. When you have a convertible note and it has a cap, it is very likely that that cap is used as the value of the next round, or or close to that, because it's a reference point. So make sure it's wiser to give to the investors a good discount on that round and have them put a larger cap than the opposite, because again, that cap is going to be used as a reference point for the valuation in your next round, and that is something I also wish I had known before.
That's a good insight. Okay, cool.
Yeah.
2 last questions. I will reverse the previous question a bit. What would 2017 Daniel think if he could see Ienai Space today?
I think he would not really believe what we've built. I think, building a team of 30 people, being about I mean, look, we had a moment earlier this year where we kind of put together the first engineering model of the whole cluster, and seeing that together, like all the systems in place, to do integration tests, we couldn't even imagine, I think, what that would end up looking like, what that would end up, what that would take in terms of efforts to get to. I think he'd just be amazed that we've come to this point.
Awesome. Last question. Where do you see European space industry in 10 years?
Look, I hope that Europe takes the reign of its own space industry. I hope that we're able to have our own ambitions, and that we are united in the space ambitions for Europe. We cannot keep relying on US launchers. We cannot keep relying on, some of the traditional partners that we've had. I think that's personally clear. And Europe needs space sovereignty. It needs space autonomy strategically for a number of reasons. And I think we need to do better at building that in a way that is coherent across the European Union, and where we're really, let's say, pushing in one direction and not trying to each country do its own thing, and and that kind of thing. There are more electric propulsion system providers in Europe than there are in the US, whilst the space market is much smaller. And it's because every country is trying to develop its own thing, right? And that's not necessarily bad. I mean, I had this discussion with a US VC. He was saying, "Oh, like the competition in space is much worse in Europe," and I was like, "It's the opposite. We have much more competition in Europe than in the US. The problem is that the pie is smaller. The amount of money invested is smaller. But if we were getting the same amount of money invested than in the US, the competition in Europe would be savage, because there is, again, many more players doing how many launcher companies, how many, again, space propulsion companies, satellite companies,
Yeah,
So I think
I'm
the competition
thinking if
is
it's good or bad, actually.
the competition is good. It's just the pie is very small. So if the pie
Yeah.
was bigger and the companies were actually funded to the point, which, by the way, it doesn't need to be the same level of funding than the US. I think in Europe we can make things cheaper, right? But
You are one of the examples.
yeah, and we're one of the examples. But if we had the right funding, enough funding, then the competition would be much better. I think we can really, really use that. It's a bad starting point, because it's meant that we've split all the funding, all the European Union funding, and all these kind of small players that are kind of like all across 27 countries or whatever. But if we use that as a starting point, it would seem that we would be in a better position to compete and to drive technological innovation through competition, as long as the funding is right for all of these companies in all of these countries.
That's an interesting perspective.
Turn it the other way around, because otherwise we're just going to all work on our own niches and not get anywhere. But if we had the right funding, and I think the competition is going to be helpful for the European and worldwide industry.
Amazing perspective and journey and insights. Thanks so much for joining Rockets and Radars. This was an amazing conversation. I really enjoyed it. Hope you too. And I hope that the listeners or the ones that are watching the video enjoyed it also. If you have any additional questions on Daniel, feel free to text him in the comments, or I will also leave a link to get in touch with Daniel in the comments. So I hope this will either spark a new success story or a new talent coming into the industry if they are not yet there.
That would be amazing.
Awesome.
Thank you so much, Martin. It's been a great
Thanks so
conversation.
much.